Hello and welcome to Math 252 Calculus 2 here at Cañada College. My name is Lapuz, and in this video we will do checkpoint 3.15. This is from section 3.3, trigonometric substitution. Here they want us to rewrite the integral using the appropriate trigonometric substitution, and it says do not evaluate, but I think we will go ahead and evaluate it anyways. All right, under the square root sign, we see an x squared plus 4, and so with a plus in between them, I would be inclined to do a tangent substitution. So let x equal to the tangent of theta, but before we get to the tangent, let's acknowledge that there's a 2 squared there, so the 2 tangent theta will be our formal substitution. And then we're going to need to replace the dx, and that's going to be the antiderivative of tangent. The derivative of tangent is secant squared theta, and then there's a 2 out in front, d theta, so that's what we'll use for the dx. I think we're ready to do this substitution. Well, let's also acknowledge that what's going to happen here is that if we take the square root of x squared plus 4 using this substitution, we will have the square root of 2 tan theta squared plus 4. This will be the square root of 4 tan squared theta plus 4. We can take a 4 out, and then we have tan squared theta plus 1. Now the 4 out of the radical will be a 2, and then this is equal to the square root of secant squared theta, which will just be equal to secant theta. All right, and again, that's the whole point in doing this substitution, so we can get rid of the radical sign. So what do we have left? We have an x cubed. We have 2 tan theta to the third power, and we just figured out that this radical will be 2 secant theta, and then the dx is another 2 secant squared theta d theta. So that is our list of trig functions. Let's take all the 2's out. That's 2, 4, and then there's an 8 here. So we have 4 times 8, I think it's 32. And then we integrate, and we have tan cubed theta remaining, and then there's secant theta, secant squared theta, so that's secant cubed theta d theta. Now this brings us to a trigonometric integral where we have secants and tangents raised to some powers. And I believe if secant was raised to an even power, we would take 2 secants out and then change everything in the tangent. That's not the case, but we do have the tangent raised to an odd power, so we'll take one of those tangents out and one of the secants out, and then we'll change everything into secant. All right, so that's what we'll do. We'll do that here. In the next step, this is going to be the constant outside, 32, the integral of tan squared theta, secant squared theta. Now we took a secant and a tangent out, secant theta, tangent theta, d theta. And then now if we can just write everything in terms of secant, the derivative of secant is going to be secant tangent, or the derivative of secant theta is secant theta tangent theta. And we can do that by changing this into something with a secant. I think we saw a version of this particular trig identity. So we'll write 32 constant outside, and then we'll rewrite this tangent theta as a secant squared theta minus 1, and then we still have the secant squared theta here, and then the secant theta tan theta. We're keeping separate because we're going to do a u substitution. U will then equal to just the secant theta, so that the du is equal to secant theta tan theta d theta, and there is the substitution that would make that work. All right, so now everything will change into u. This is a 32 integral of u squared minus 1 times u squared, and this whole thing just becomes du. All right, so 32, and before we integrate, let's multiply everything out. U to the 4th minus u squared du. That's a 32, and I'll put a parentheses. This will be a 1/5 u to the 5th minus 1/3 u to the 3rd, and then we'll put a plus c. Change everything back in terms of theta. That's secant theta, so wherever we see a u, we'll replace with secant theta. We'll have the 32 out here, and we got 1/5 secant to the 5th of theta minus 1/3 secant cubed theta, and then plus c. We're not quite finished yet because our original integral was all in terms of x, and so we're going to need to somehow change this back in terms of x. We will use the information or the initial substitution that x is equal to 2 tan theta to help us figure out what the secant of that same angle theta would be. So x is equal to 2 tan theta, and then we write that as tan theta is equal to x divided by 2. And remember that if we have a right triangle and we have an angle theta, the tan theta will be the opposite over the adjacent. So we have x over 2 there, and we can solve for this, and that is going to be the sum of the squares of these things. So it's x squared plus 4. Again, not a coincidence that that was our original radical that was sitting in our integral in the first place. So now that we have that, we can find secant theta. Secant theta is equal to 1 over cosine theta, which is 1 over cosine is adjacent over hypotenuse, so that's 2 over the hypotenuse, x cubed or x squared plus 4, and then we'll just take the reciprocal back. Let me write it down lower here. Secant theta is equal to the square root of x squared plus 4 divided by 2. And that's all we have here. And so we will have this to equal to 32 times 1/5, and then I'll just put everything in parentheses, the square root of x squared plus 4 divided by 2 raised to the 5th power, and then we have a 1/3 square root of x squared plus 4 over 2 raised to the 3rd power, and then plus c. We can simplify these things. I think 2 times 2 times 2, 2 times 2 is 2, or 4 times 2 is 8, times 2 is 16, times 2 is 32. So this thing distributed out would cancel the 2 to the 5th, so I'll just have 1/5. And then I'll write this as x squared plus 4 to the 5/2 power, because that's power of 5 with a radical. And I have a 3 in the denominator that won't cancel with anything, and I have 2 times 2 is 4 times 2 is 8, and then we have a 32 here, so 8 goes into 32 4 times, and that will leave with a 4 in the numerator. and then I'll have a x squared plus 4 to the 3/2 power plus c. So this could be an answer. This is just one form. This previous form is just fine, but we can look at it in different ways. So that's it. I hope that helps.